Alright guys, here we go. We're going to work on extra practice, page 13, 17 through 25 odd, and then number 26. If you already did it, look at the answers first, and if you got them all right, great, you get it. You can just skip the rest of the video and move on to whatever you need to do, okay? Anyways, the answer for number 17 is 5, the answer for number 19 is 6, the answer for number 21 is 15, and the answer for 23 is 30, and the answer for number 25 is 4, and for 26, the answer is 20 years. Alright, let's get started with this. Again, number 17. Now, I know in the book it does it already for you and so forth. And you're like, why are we doing it again? Like I said, it's one thing to know the answer, but to actually understand how they got it. And they do show the work there for one way, but I'm going to show you the other way, the prime factorization way. Again, it's just good to know how to do this. So 15 and 20, we're looking for the GCF. Okay. And again, like I said, with the independent practice, you just look at the number first. All right. It ends in a 5, so I know I can make groups of 5 out of it, or that 5 is a factor. How many groups of 5 can I make? 3. Those are both prime. Done. Okay, it ends in a 0. I know I can use 10 as a factor. I make groups of 10. How many groups of 10? 2. 2 is prime. 10. I can make 2 groups of 5, or 5 groups of 2. Right? And then let's go ahead and write down the factors. 2 times 2 times 5. Alright, since we are looking for the GCF, and you know I did forget to write that, I could have easily looked for the LCM. I'm going to write down now. The GCF is what they share. They both share a 5. That means I can make groups of 5 out of both of them equally. And there you go. Bam, boom, bam. Alright. I'm not going to explain too much because I did that in the independent practice and the guided practice. Again, you can do what they did in the book, and that's fine as well. 19. Let's see, now we get numbers like this, 24, 30, and 42. Again, you do what works best for you, but I'm going to continue using prime factorization. 2 times 12. I'm going to go a little faster, guys. I think you already know how I work with this. Right? Again, it's an even number. I can make groups of 2. How many groups of 2? 12. Even number. I can make groups of 2. How many? And so forth and so on. 30. I can make groups of 3. How many groups of 3? 10. And so forth and so on. I'm going a little fast. Okay, it's a bigger number. It's an even number. 2 times 21. Now, don't forget, again, this really is a division problem if you think about it. I have 42. I'm breaking it up into groups of 2. And if you do the math, you'll find out that it's, and I think I've told you this before, and I'll say it again. If you need a calculator, go ahead and use it. Okay? I'm not testing you on whether you can divide or not. I just want to know you can break it down. So if you know, you want to use a calculator, go ahead. I'm not going to be all, it's the way it is nowadays. Everyone has a calculator in their pocket. Your cell phone. Before, you didn't really have one on you. You had to really do everything in your head. But saying what I just said, let me say this again. Because I said it before in the beginning of the year. You really should try to do these things in your head if you can. Okay, we're doing paper and pencil. You'll make stronger brain connections this way. It's you doing the work and not the calculator, not the machine. Okay? But I leave it up to you. You decide what works best for you. Alright, 24, 30, and then 42. Alright, I have 2 as a factor. How many 2's? 1, 2, 3. Now you're thinking, why don't you write the exponents? No, just if I write the exponents, it's harder to see what they share. I mean, I can see it, but since we're barely starting, it might be harder for you guys to see it. So later on, I will show you, but right now, no. And then there's a 3. And then 30, there's a 2, there's a 3, there's a 5. And then for 42, we have a 2, a 3, and a 7. All right, we're looking for GCF. So what do they share? They all share a 2. And they all share a 3. Am I missing anything? I see 2's here, but not here. I see 5 anywhere else. Okay. GCF. equals 6. Okay. Now see, you saw me hesitate, right? Like, oh wait, am I looking for GCF or LCM? So again, don't do don't make the same mistake I did. Write down what you're looking for right away, so in case you forget, you can look back. Oh yeah, I'm looking for that. Just a word of warning. I mean, even us old pros make mistakes like that. So if you did find the LCM, don't worry. You're still doing work. It's just, what is it? What I like to say, it's the right answer to the wrong question. It's still valid. You still did the work. All right. All right, 21, and we're looking for the LCM, 21. So I'm going to do right now, I'm right away. LCM of, and I'll write the two numbers. There you go, LCM. I wrote LCM of, so don't forget, I'm looking for the LCM. Oh, this is way too easy. Okay, they're both prime. Write down all the different factors. We just have a 3 and a 5. All right, 3 and a 5. No exponents to worry about. 15. So the LCM. Okay, so the LCM is 15. The video got cut off. I had to take care of something and then edit that thing out. So sorry if it's a little choppy. But we're good now. So again, the LCM is just 15 for number 21. We're going to go ahead and do number 23. And it's another LCM problem. Least common multiple. I'm going to write down LCM, so I don't forget that's what we're looking for. 5, 10, and 15. Okay. Now look, just a quick reminder. LCM, we already know the size of the groups. We have groups of 5, groups of 10, groups of 15. We're looking for a common product. Okay? For whatever reason, we have to match up the packages or the boxes or however you want to imagine this. Remember when I give you the hot dog example, hot dog and hot dog bun? You have to have a common product. What's the smallest product that we can get? All right. Now I'm going to go ahead and use prime factorization. 5 is just 5, prime. 10, I notice it ends in a 0. I can use 2 as a factor because it's even. It also means I can divide it by 10. But that doesn't help because it would be 10 times 1. That doesn't help me keep going forever. But that also tells me 5 is a factor. I can make groups of 5. So 2 times 5. 15. If you notice, I'm going a little faster because right now I think you might be getting the gist of it. All right, 5, 10, 15. I'm going to write all the factors. And 10 is just 2 times 5. 15 is 3 times 5. All right, LCM. I'm looking for all the different factors. We're going to multiply them together. All right, we have a 2. We have a 3. And we have a 5. Now, you notice how the 5 is shared by all of them. If we're looking for GCF, the answer would be 5 for GCF. But here we go. I'm going to underline because it's not really a highlighter. I don't want to mark it. So I'm going to do that. Okay. All right, so we have a 2, a 3, and a 5. We don't have any exponents to worry about, so we're good. 2 times 3 is 6, times 5. That leaves me 30. LCM is 30. Okay. I think some of you are getting the hang of it. I hope. Just know your times tables. Really, that's all it is. $25. All right, here we go. Another word problem. Let me read to you. This is page 13. A grocery store clerk has 16 oranges, 20 apples, and 24 pears. The clerk needs to put an equal number of apples, oranges, and pears into each basket. What is the greatest number of baskets that can be made so that no fruit is left? Okay, so we're talking about oranges, apples, and pears. Okay. Just real quick, my orange, I guess. 16 oranges, 20 apples. Okay, that's not, well, again, I'm not an artist. Here are my apples. We have 20 apples. And we have 24 pears. Hopefully. Oh, God, that's a... I can't. Oh, jeez Louise. I'm going to write the words, too, just in case you're looking at this like, what are you doing? I'm laughing because my drawings are horrible. But you know what? If it makes you laugh, hey, all for it. Do it. Oranges, apples, and pears. All right, so somehow we got to separate all these fruits into baskets. All right, and we got to have it so that the amount of fruit in each basket is the same. Right, each basket will have the same amount of apples, the same amount of oranges. It's not saying it's going to have equal number of oranges, equal number of apples, equal number, because you can't. That's impossible. We have 16 oranges, 20 apples, and 24 pears. But also that tells me I'm not getting more. I'm not getting more of this. So I'm not looking for multiples. I don't have to match the product here. I don't have to get multiple oranges to match to multiple apples. It looks like I have to break it up into groups, right? If I have to put it in baskets, that means I have to put it in groups. So that means I have to look for the GCF, okay? Greatest common group. 16, 20, 24. And I'm going to go a little fast, okay? I always start with 2 just because that's my habit. Again, the advantage of me recording this is you can rewind this as many times as you need. And you can hear my awesome voice many, many times. I'm teasing about that last part. All right. 2, 2, and 5. And 24. 2 times 12. 2 times 6. 2 times 3. All right. Let's write it down. Let's see what we have. I'm just looking at my work. Make sure it's right. If you go too fast, honestly, you do make simple mistakes. I hope I didn't make one because I went maybe a little too fast. All right, I have 2 as a factor. How many 2's do I have? I know, use the exponents. Bear with me. I don't want to go too fast on it because if I go too fast, this is where I really will make a mistake. All right, 2 times 2 times 5, and then 2 times 2 times 2 times 3. All right, now I'm going to go ahead and use exponents to make it easier to write. All right, I have 2 times 2 times 2 times 2. That would be 2 as the base, and the exponent would be 4. That means I'm multiplying the 2 4 times. All right, by the way, this is not 8. Don't think it's 8. It's 2 times 2. 2 groups of 2 is 4. 4 groups of 2 is 8. 8 groups of 2 is 16. Okay? But anyways, and this is 2 squared, and then this would be 2 to the 3rd power. Then you have a 5 here as a factor, then you have 3 as a factor. Okay. Now, here's the deal. Earlier, in one of either the IP, GP, I forgot what I was going to tell you. If you do the exponents, you can also use this to find the GCF, right? Not all of them share a 5, not all of them share a 3. They all share a 2, but then you have to find the smallest one for the GCF, because it's something, all of them have at least 2, right? This has 4 2's, that means it has at least 2 2's, 3 2's, there's at least 2 of them in all of them. But see, this is what I'm saying, for GCF, it's just easier if I see it this way. You can share, you can see what they're sharing easily, right? But we're looking for LCM. Actually, no, excuse me. See what I almost did? Do you see what I did right now? What didn't I do? I forgot to write down that I was looking for GCF, and I started looking for LCM automatically. Now, I'd like to say I planned that. I didn't. I totally forgot. So, please don't be a me. Whatever it is you decide that you're looking for, write it down. Because I almost went to this. I almost wrote down the LCM. And that's not what I'm looking for. I'm looking for the GCF. So now I can show you what I was going to show you anyways. What do they share? They share a 2. They share another 2. What did Bob Ross say? There are no accidents. There are no mistakes, just happy little accidents. Yeah, this is a happy little accident. Happy that I caught it in time. Okay. But see, remember what I said earlier? There's at least 2 2's. Each of them share at least 2 2's. Smallest exponent tells you that. But regardless. So 2 times 2 is 4. But what does that mean? What does that mean? Now, let's go back to the question. What is the greatest number of baskets that can be made so that no fruit is left? 4. 4 baskets. So, and again, it looks like an acorn, but it's supposed to be a basket, so don't judge me too harshly. 4 baskets. Ooh, that was not a good basket, but okay. So let's apply that. 4 baskets. If we have 16 oranges, that means there's 4 oranges per basket. If there's 20 apples, 5 apples per basket. If there's 24 pears, 6 pears per basket. You know what? I'm going to go ahead and write that down. 4A, A for apple. Whoa, oranges. Excuse me. Oh my goodness, I know it looks like 0, but it's oranges. 4 oranges. 5 apples. Now I can use the A freely. Pears, 6P for pears. Alright, now let's say you guess and put down 5 baskets. 5 baskets, you'd have 3 oranges, 3 oranges, 3 oranges, and then 1 orange. That messes up. It messes up the equality of it. You want equal amounts of fruit in each basket. Equal oranges, equal apples, equal pears. 4 baskets is what works out. Again, remember I told you the size of the group? Either the size of the group or the quantity of the group. So we're not looking for groups of 4, but we do want 4 groups, 4 baskets. Okay? Alright, I hope this helped.